Class, and welcome to lesson 5.5. Today we're going to learn the fourth method and the final method of factoring. Just a quick review, folks. The different methods you should already know is 1, common factoring. That's where you get a monomial or a common binomial out front, and the leftovers go in the bracket after you divide each term by the greatest common factor. Second method we learned was simple trinomial factoring, and that's where a equals 1, and you find the product and sum, and you can simply put the answer right down into the brackets. The last method we learned was decomposition, and that's the harder version of trinomial factoring where a does not equal 1, and that's where, although you found the product and sum, remember the product was a times c, and we decompose the middle term, so we split the middle term into 2, and we'll be taking a look at a couple of these questions in our warm-ups. And today, the last method we're going to learn is called the difference of squares method. All right, so after this lesson, folks, you should be prepared for a quiz coming up, and then review day, and your part 1 unit test for unit test part 5A, or 5A unit test, okay? So let's take a look at question 1. Question 1 means to expand. That means to multiply. So pause the video right now, folks, and try these warm-ups, and then after, unpause it and check your answers. Pause it now. Okay, welcome back, class, and hopefully you had a good chance to get your warm-ups going here. First example is FOIL, first, outside, inside, last. So you should have here 6xy minus 2x squared y minus 12xy squared and plus 4x squared y squared. All right, that's the first one. Now for the second example, I'll show you 2 ways. I'll show you the expansion one first. So you expand both binomials, and then you use FOIL. So first, outside, inside, and last. It's a minus 10d there, folks, sorry. Okay, and then collect like terms, so the negative 10d and the minus, let me just make that look better. So that's negative 10d if you're wondering, okay? And now collect like terms, the middle 2 terms there, so it's going to be minus 20d plus 25. Or, folks, I will show you the shortcut method. We'll do it up above. Okay, and it can be done in one line. Square the first, so 2d squared is 4d squared. Double the product, so 2 times 2d times negative 5 is going to be minus 20d. And square the last, so negative 5 squared is plus 25. So you could do that method or the expanding method, which I showed down below. So remember, guys, expand means to multiply. Okay? The opposite, ladies and gentlemen, is what we're doing is called factoring. It says to factor fully, so look for more than one method. And whenever we factor, folks, we're going to remember that we're dividing, or we're going to look to divide. Okay? Let's take a look at the first example. So always try to common factor first, folks. So hopefully you realize that in the first example, there's a common 3 out front that you can take out. So make that your greatest common factor. Divide every term by 3. So you should have in the bracket c squared minus c minus 30. All right. Don't forget to continue to look inside the brackets. Notice that we've got a trinomial factoring where a equals 1. So product equals negative 30. That's your c value there. And our sum equals negative 1, and that's from our b value that's there. Now we have to figure out, hey, our product is negative 30, so that means 1 has to be positive, 1 has to be negative, but since the sum is negative, that means the biggest number has to be negative. So 1 times negative 30, 2 times negative 15, 3 times negative 10, and 5 times negative 6. So all of those meet the product case, but only one will meet the sum case. So which one sums to negative 1? It is the 5 times negative 6. So you leave the 3, which is your common factor out front. You set up 2 brackets. Take the square root of the first term, which is c, and then you take your factors in with the sign. So plus 5 and minus 6. All right. Take a look at the second example, ladies and gentlemen. Always look to common factor first, so we can take a 4 out, but also note here, folks, we can also take an f squared out. Okay, but before we do this, notice that these aren't in highest order, so let's just, I'm going to put a little line in here and simplify it so I've got more room in here. Okay, I'm going to put them in order in terms of highest degree, so we're going to go 48 f to the 4th first, and then we're going to go plus 4f cubed, and then minus 12f squared. Okay, now that they're in order in terms of their exponents, now we're going to take the greatest common factor out. It just is easier when they're in proper order. So we're going to go 4f squared as our greatest common factor, and after we divide each term by that, we're left with 12f squared plus f minus 3. Okay. Notice that in the brackets, folks, we still have a trinomial, so we're going to see if we can still factor it. Notice that it's going to be a decomp, so our product will equal 12 times negative 3, which is going to be negative 36, and our sum equals 1. Okay, so if our product is negative 36 and our sum is 1, the biggest number has to be positive. So 1 times 36. Negative 2 times 18, and negative 3 times 12, negative 4 times 9, and negative 6 times 6. Does any of these sum to 1? Actually, no, they don't. So then there's no further factoring. And next unit, folks, we will learn how to use that doing the quadratic formula, or next part of the unit. Okay, let's take a look at a harder example here, and this is C. Okay, this is a trinomial. We take a look, can we factor out a greatest common factor? In this case, we can't, so we're going to deal with some bigger numbers. And this isn't typical, but it's still possible to do this. So the product equals 21 times negative 21. Product equals 441. Okay. And our sum equals 40. Okay, so if you're plugging away in your calculator, I apologize, it's negative 441, folks, so make sure you got that in there. Okay, I'll highlight it with different colors so you make sure you see it. Okay, negative 441. And if the product is negative, folks, that means we have one positive, one negative. If the sum is positive, the biggest number has to be positive. So let's think of our factors. We know it's negative 1 times 441. Okay, 2 doesn't go in, does 3? Well, remember the shortcut. 4 plus 4 is 8 plus 1 is 9, so that means 3 must go in because it's a multiple of 3. Okay, and use your calculator. It's going to be 147. Then 4 doesn't go, 5 doesn't go, 6 doesn't go, but 7 does, so negative 7 times 63. And taking a look at next one that goes in is negative 9 times 49. Okay. All right, taking a look, is there one here, ladies and gentlemen, that has the sum of 40? That's this one here. Okay, because this is decomposition, we're splitting the middle term up, okay? So we write the first term as is, 21q squared, and then I'm going to go minus 9q plus 49q and minus 21. Okay? So now I've split the middle term. Now I'm going to say, hey, what's common in my first two terms? Okay, and that's going to be a 3 and a q. So what's left over? 7q minus 3. In the last two terms, what's common? I'm going to say 7. So it's positive, so plus 7, and what's left over? A 7q minus 3. Notice, folks, that you've got the same binomial. That's going to be your greatest common factor, so that goes out front. Okay, and your leftovers are 3q plus 7. That was a hard one, ladies and gentlemen, but again, you still should be able to do it even with bigger numbers. All right, this next one, ladies and gentlemen, that's a little bit interesting. However, it's interesting because we've got two variables. However, look to see if we can cancel them out. Notice that everyone has a p in it, so we could common factor Sorry, I didn't mean to say cancel. Common factor out a p, and we can also factor out a 5. So our greatest common factor is going to be 5p. Divide everything through, and you should have q squared plus 3q minus 28. Okay? Don't forget to keep looking in the brackets for factoring, folks. So our product is going to be negative 28 because it's simple. There's no a times c, or a is, remember, 1, guys. So 1 times negative 28 is still going to be negative 28. Sum equals 3. Okay, what factors can we come up? Well, first of all, product's negative. That means one has to be negative, one has to be positive, and our sum is positive, so the biggest number has to be positive. So negative 1 times 28, negative 2 times 14, and negative 4 times 7. Which one of those sums up to 3? It's the bottom one. All right, so leave the greatest common factor out front. Oops, sorry, not a p. P's out front, and then the q's are inside. Okay, so let's try that again. Okay, then we set up two brackets, square root of the first, okay, and the signs that attach to your factors that we just found out. Awesome. So that's good practice at factoring, folks. Again, if you need some help with that, please come see me. And let's learn that last method of factoring called difference of squares. So here's your handout, folks. Difference of squares, and we're factoring it. So let's just recall expanding, and I want you to just look at this example. We got an f plus 3 and an f minus 3. So if we FOIL this out, we're going to have an f squared minus 5f plus 5f minus 25. If we go to collect like terms, what do you notice about the two middle terms, folks? A negative 5f and a positive 5f will cancel out. So we're going to be left with what's called f squared minus 25. Notice that the two middle terms cancel out and the remaining terms are both perfect squares. So what we do is we're going to now look backwards and factor. Okay? So what we need to realize is we're going to start with a question like this. Okay? And how do we recognize this factoring method? It's a difference, meaning subtract sign, of squares, of perfect squares. So it's a binomial with a subtract sign in the middle where the both terms can have a square root taken evenly out of them. Okay? So that's what the title tells you in itself. Difference of squares. All right, there are two ways to look at this, folks. Method one, you might like this. We relate it to trinomial factoring, okay, where b equals 0. Why? Because ax squared plus bx plus c, there's no middle term here with an f in it. So if I was to rewrite that, folks, it's really f squared plus 0f minus 25. Okay, just if you're trying to think about relating it to trinomial factoring. Because 0 times anything is 0, so it cancels out. All right, so we can still do this method of factoring, though, because a equals 1, b we know equals 0, and c equals negative 25. Doing that, folks, let's think of our product. Our product is going to be negative 25, and our sum has to equal what? 0. If our sum has to equal 0, that must mean that our values have to be exactly the same, except for opposite signs. So what two numbers multiply to negative 25 and give you a sum that's 0? And those numbers are negative 5 and positive 5. Okay, or negative 5 times, if you want to go back to what we've been doing before, you could say 5 times negative 5 or negative 5 times 5, doesn't matter. There's only one case there. The other case you could take a look at is negative 1 times 25 or 1 times negative 25, okay? And the only one that has a sum of 0 is this one. So you do the same thing you did before, set up the two brackets, take the square root of the first, which is f, and then you take the signs, negative 5 and positive 5. In order, folks, for the middle terms to cancel out, these two terms have to be the same value except opposite sign. So if you like this method, it's always going to be like a plus a number and minus the same number. Okay? That's one way to do it. So if you like that, stick with it. However, please let me tell you that this second method might be even easier for you. Okay? Difference of squares method. So when you take a look at method 2, all you need to realize is that when you take the square root of the first term, you're going to take the square root of the last term, and you're going to set up brackets so that one is positive and the other is negative. Why? Because we need that middle term to cancel out when we expand it. All right, so write these steps down first. Don't forget, ladies and gentlemen, to try the common factor first. I already told you that difference of squares method is a binomial with a difference of squares. Make sure you know how to recognize that. So write the steps down, folks, and I'll show you how easy this one is. So method 2, it says to factor. Look to common factor first. So for example, A, we can't common factor anything out because A is 1, folks. All right. So it says, step 1, set up 2 brackets. I got it. Okay. Add a plus sign and a negative sign. Doesn't matter which one you go first. I always go positive, then negative. Okay. Take the square root of the first term. So square root of x squared is x. Okay. Square root of the last term, square root of 36 is 6. Okay. And you're done. That's it. Pretty cool, eh? All right, let's try example 2. In example 2, look to common factor first. Is there something we can common factor out? Yes, a 4. When we common factor a 4 out, we're left with x squared minus 9. Continue to look in the brackets, because in the brackets, folks, again, you have a difference of squares. So to do that, set up 2 brackets. Put a plus sign and a negative sign in. Take the square root of the first, which is going to be x. Square root of the last, which is going to be 3. And you are done. Let's try C here, folks. Okay, what's common here? And you're going to see it's a 2. Okay, and what's left over is 4m squared minus n squared. Okay, look inside the brackets and notice it's a difference subtract sign of perfect squares. So we're going to continue on by doing by a difference of squares factoring. So you set up 2 brackets, one positive, one negative, square root of the first. So you got to square the 4 and take the square root of the 4 and the m squared. So it should be 2m for both terms at the beginning, and the square root of the last, and square root of n squared is just n. All right. Couple more here. We've got some starred ones coming up. They're lovely. I love them. I know you get excited, right? Always get harder. Okay, taking a look at D, folks. Look to common factor first. Hopefully you realize that you see an A that's common and a 3. So you're going to take out 3A. What's left over is A squared minus 4B squared. Okay, look in your brackets. You should still recognize a difference of squares. So we're going to set that up. And this time I'm going to put a negative, then a positive. Doesn't really matter. Okay. Take the square root of the first, it's going to be A. Square root of the last is going to be 2B. And you are done. Now E is a tricky one, and you got to watch because some nights in your homework they give you this one. Okay? So this is tricky in that it's a difference, okay, of perfect squares. How can I tell? Because they've got squares attached to them right here and here. I'll erase it so it's not going to bother you, but that is a difference of squares. The problem is instead of having a monomial subtract a monomial, this is a binomial subtract a monomial. Okay, so here's what I'm going to do. I'm going to set up 2 bigger squares, or bigger brackets. I'm going to put a positive sign in one and a negative in the other. If I take the square root of x plus 3 squared, we're left with x plus 3. Whereas and that's for this one, right? Whereas if I take the square root of 2x squared, what's left over is 2x. Okay, and then we just simply collect like terms in each bracket. So you got 2x plus an x is going to be 3x plus 3. And look to collect like terms here. We've got x minus 2x, which is going to be negative x plus 3. All right, that's a tricky one. All right. F is also tricky, guys, and I'll show you why. When I go to recognize this as a difference of squares, that's fine. However, what do I realize? My exponent is to the power of 4. So if I'm going to take the square root of it, okay, you're going to half the exponent. So it's going to become x squared plus 4 and x squared minus 4. Okay, Here's the thing you want you to be aware of. This is what makes it tricky, folks. This is an addition of perfect squares. However, we still have it in the red here a difference of squares. So we're going to continue on with that. We can't do anything with the first bracket, so we leave it the same because that's an addition of squares. But this one we're going to break down even further. Okay? So square root of the x squared is x. And square root of 4 is 2. Okay, how can you tell when you can do more than one difference of squares if your exponent is greater than 2? Okay, guys? So keep an eye on that one. Okay, and the last one here, folks. Okay, notice, ladies and gentlemen, can you common factor anything out? You can common factor out of 4. So you take 4 out, and what are we left with? We're left with 9g cubed plus 1. Look in the brackets, ladies and gentlemen. Do we have a difference of perfect squares? No, we actually have an addition. But how come this can't be perfect? Because you can't take a square root of an odd exponent. So because it's odd and because there's addition here instead of subtraction, okay? Sorry, not additional, just addition, okay? There's therefore no further factoring. So you can only common factor that one out. And reality tells us, folks, that most quadratics cannot be factored fully. And this, in case, was a cubic, folks, okay, because it was to the power of 3. All right, ladies and gentlemen, if you need help with this, please come and see me in the Math Science Help or during my lunch hour. Come and touch base with me. Here's your homework, folks. Page 248, numbers 2, 3, and 4D. Please also study and prepare for your upcoming quiz and your 5A test. Check the website or with your teacher, Miss R, to tell you when those exact dates are. Thanks and have a great day, guys.